Okay. So we're going to start with the discussion of the concept of sets and induction. Okay. Now, once we have the sets, we usually recognize the name of George Cantor, no, who developed the theory of sets as an outgrowth of his studies on infinity. Okay. Now, his work has become the milestone in the development of mathematics. In geometry, we use the set as yung line to describe the line. No? Line is a set of points. So meaning, nandun pa rin yung set ng tinutukoy natin. And even in real numbers, we have different assumptions regarding the concept of sets natin. Yan na. So one of the most fundamental notions, sabi dito, in any part of mathematics is that of set. We have set will be just a collection of entities or a group of well-defined objects. Okay? So pinag sinabi nating sets, it is a group, no, enclosed by the bracket. Ano, the parentheses. Enclosed by the bracket. Okay. Okay, then elements is the member, or under the set we have the elements. Okay, so we indicate that sum of x is an element of a set S. Okay, writing x is an element of S, and if the value or the x is not an element, then we have the symbol x is not an element of set. Okay, so let us say, for example, okay, if S is a finite, then we can do this by writing down all the elements inside the braces. Okay, when x is infinite, then we usually have the ellipses on the three dots. Now, there are three types kasi ng sets natin. Tignan. Okay. The first example of a set is we have the finite. Okay. Sabi dito, the finite set. Pag sinabi natin finite, then we can count the number of elements. Example of this one is the given set. We have this the set of S having the elements of 1, 2, 3, and 4. So we have the last element, which is 4. Okay. So this is an example of the finite set. Pag sinabi natin finite, we can count and we have the last element as defined. We have the number of n elements here is 4. So this is an example of a finite set. Okay. Another example is we have this one. Ano na yung counterpart ng finite? So number 2 is the infinite set. Okay. So ang infinite sets natin, we usually describe this using the ellipses. Okay. So meaning if we have 3 dots here, then we have still elements. So infinite yung number of elements natin dire-diretso. So we don't have the last element as defined in the given set. So this is the finite set. Indicates the set of all positive integers that are of the form 1 plus 3k for some non-negative integers. Okay. So for example, the set of negative numbers. So the set of negative numbers is an example of infinite set because we don't have the last element as defined. Okay. Pag sinabi kong the set of vowels, so the set of vowels is infinite or finite? Tingnan natin. So anyone po?
Finite po to.
Finite because we have, pag sinabi nating vowels kasi already defined that this is a vowels, therefore we have 5 elements. Okay? Pag sinabi kong set of counting numbers, then this is an example of infinite. No? Because we don't have the last element for what we call the set of the counting numbers. Pero pag sinabi kong set of counting numbers from 1 to 8, then this is what? The set of counting numbers from 1 to 8 is example of finite or infinite?
Finite.
Finite na siya because we have the last element, which is 8. Then the third one is we have the null set, no? Or empty. So empty sets. Pag sinabi natin empty sets, or we have the symbol, wait. We have this one, or a braces na magkaharap na walang laman. So this is the null set. When we say null set, this is a set with no element. Okay? Example. The set of negative integers greater than 0. Okay? The set of negative integers greater than 0. Is this an empty set or a null set?
Null set.
Kasi
Wala naman pong negative na greater than 0.
okay, so that is an example, but still that is an example of a set. Tignan natin. Kahit walang element, still yun pa rin yung value ng yun pa rin yung i-describe pa rin natin siya as a set. Example of this one, the practical example of a null set is pag nilagay ko yung set of guava doon sa sa basket na 5 na variety ng guava, and we have put this one inside the basket, then that is example of a finite set. Tama? In-enclose siya ng basket. Now, the practical example naman siya ng empty set is, meron tayong basket na walang laman. That's why the representation of that basket is the braces. So, ibig sabihin, that is an example of a null set. Ang magre-represent ng mga braces natin ay yung basket. Naka-enclose siya pero wala siyang laman. Okay, so that is an example of the practical example of the null set. Okay. Now, we can also specify a set by giving a criterion that determines which objects are in the set using the method. The set of 1, 2, 3, 4 could be denoted by an x such that x is a positive integer less than 4. Okay, so let us continue. We can also specify a set by giving a criterion that determines which object are in the set using the method, the set 1, 2, 3, 4. So dito, let us say for example, there are two ways kasi in describing set. Tama? I still remember that? Anyone?
Yes,
Yes.
po, Doc.
Dalawang way lang yan. The first one is
Set builder.
yung set builder natin. The
Tsaka
first
yung
one is
Rooster method.
yan. Tama po. Thank you, Ma'am Teo. The first one is the rooster method. Tama? So anong ginagawa natin sa rooster method?
Parang we just simply list down the elements.
Okay, so we're going to list down the elements. So list down natin. Like for example, the set of the positive integer less than 4. So we can say that, okay, let's say for example, set of S is a set of positive integer less than 4. So we have S, yes, we have 1, 2, 3, and 4. So this is an example of a rooster method. Like for example, the set of S is a set of whole number. Okay. Set S is a set of whole number. Okay. So how we're going to have? What will be the first element that we're going to list down?
0, sir.
0. Thank you, ma'am. So we have 0, 1, 2, 3. Then we have the ellipsis because this is an example of infinite. Tama? Okay. So this is how we use the rooster method. Okay. The second one is yung set builder natin. This is an example. Tama po yung second one. Okay. That we're going to use yung in layman's term, ang tawag natin dyan ay rule method. Tama? Yung rule method natin is we're going to define the elements. Dito, list down. This one, we're going to define the elements. Okay? Wherein set of S is equal to the X such that X is a positive number less than 4. Okay? Pag dito naman, how we're going to have this, S is equal to, we have X. Yung X natin will specify what are the elements inside such that X is an element or is a set of whole number. Okay, then we have to enclose this one. So this is how we're going to describe the given set. The first one is the rooster and the second one is the rule method. So yun lang naman. All you have to do is list down the elements and that is a rooster, and rule will be you're going to define the elements. Okay? Okay. Some sets occur so frequently that it is worthwhile to adopt spatial notations for them. For example, we use the Z. Okay? Kung mapapansin natin, yung set natin is we have this Z. Yan. So this is the set of all integers. Alam naman natin, we have integers. How we're going to define the set of integers? Anyone? Okay. Pag sinabi kong set of integers, paano po natin i-define yan? Or how we're going to describe the set of integers?
Parang, sir, set of negative and positive numbers including 0.
Yes po. Thank you, ma'am. So the set of integers are the set of positive integers, negative integers, including 0. Okay? Now we have notations also. Pag sinabi nating alam natin na pag ganito, okay, we have this and we have plus. This is the set of what? Yan. This is the set of positive integers. Okay. Well, the counterpart of this one is we have this, the set of what? Anyone? Kung ito, pag nakita natin, ito, dali, masyadong mahirap magsulat. Yan. Kung mapapansin nyo, dinodoble ko yan para ma-aware tayo doon sa mga symbols. So this is the set of positive integers. How about this? This is the set of negative integers. So we have two subsets na mga yan. Okay, next we have this one is the set of rational numbers. So how we're going to say or describe the set of rational numbers? Yung Q natin. It's a set of what? Yung pinaka natin. Rational numbers from the word ratio, no?
Sir, pwede po magsalita.
Yes, ma'am. Sige lang po.
Okay po. So, parang ang rational numbers are can be expressed as quotient between two quantities.
Yes, two quantities, and then you have A all over B, no? As long as B is not equal to 0. Tama? So, yan. That's a ratio of two quantities. No? So, this is a set of wherein you can express this one as A all over B as long as B is not equal to 0. Because if the value of B is equal to 0, then this will give you undefined. The counterpart of this one is irrational number. Yung irrational number natin. Those numbers cannot be expressed as A all over B. Example of irrational numbers as square root of 2, yung mga yan. So hindi pare-pareho yung decimal point nila pag kinonvert natin. Example is the value of pi, di ba? The value of pi is 3.1415 and so on and so forth. So hindi na pare-pareho. But if you're going to have 0.25, 25 and 25, so the same na yan. So this is an example of rational number. Okay, rational yan. Pero pag sinabi natin 0.333, yan. Example pa rin yan ng rational numbers because the decimal point are the same, paulit-ulit. Unlike ng square root of 2, hindi yan pare-pareho and the value of pi. Pag kinonvert na natin into decimal at hindi na yan pare-pareho, and we have still numbers, no? So that is an example of irrational numbers. Okay. Dali. Okay, then we have the set of real numbers. Dalawa lang naman ang set of real numbers in general, no? We're going to have a set of real numbers composed of rational and irrational numbers. Or yung lahat ng klase ng number ay example ng real numbers. Dali. Example of this is pag mayroon kasi tayong real number na ganito, may umbrella tayo dito ng set of Q and set of yung irrational number. Usually, terminal point na yung irrational number natin dyan. Kasi we're going to have this, meron tayong set of integers, tama? Then under this set of integers, meron tayong subset niya na naman is the set of yung counting numbers or whole numbers. Then we have the set of what we call the set of n. Okay, so titingnan natin later on. Okay, so dito we have the set of complex number. And the set of complex number, nandito rin yan minsan sa may Q, naka-separate na yan. Okay, ang set of complex number, we usually have this as in the form of A plus BI, tama? Wherein the value of A and B are real numbers and I is a complex number. So why complex number exists? Tama? Why negative or complex number exists? Naalala niyo yung sa history ng math? Why the complex number exists? Bakit nilabas ng mga mathematician ang complex number? Yes po? Naalala niyo yung solving solutions of quadratic equation using the what we call quadratic formula, wherein magkakaroon tayo ng negative numbers inside the radical sign. Like for example, nag-end ka ng square root of -4. Tama? If you're going to use your calculator, can we possibly find the -4 square root?
Wala pong square root. There's no square root po for negative numbers, di ba, sir?
Opo. Kaya nga, nag-exist po ang complex number. So, tingnan natin. In complex number, it is already defined that the square root of -1, so wala naman tayo niyan, no, is equal to I, or the complex number part. Therefore, if we're going to have the square root of 4, the square root of 4 now, so this can be written now as, we are going to factor out. So 4 times -1 is -4. No? So it is already defined that the square root of -1 in the complex number is I. So 4, square root of 4 is, yan na. We have the real number part, 2. Square root of 4 is 2, and the square root of -1 is I. That's why the square root of -4 is 2I. Okay. So this is the concept of having the complex number. We factored out, no, using -1 para magiging positive yung real number part natin. Okay? Now, sabi natin kanina ni Ma'am Teo na additional, yung mga subset natin. Pag sinabi kong set of full numbers, okay, set of W, no? Or the set of whole numbers. The elements under this one, if you're going to describe this using the infinite, 0, tama, Ma'am Teo, tama. 0, 1, 2, 3, 4, and so on. Okay, so this is the set of whole numbers. Pag sinabi kong set of natural numbers, saan tayo mag-start? Pinakamabab. Yes, Ma'am Maris po. Starts with sa 1. Because 1, 2, 3, 4, and so on and so forth. So 1 because we're dealing with natural number. Natural numbers are set of counting numbers. Set of counting numbers. Okay. So this is an example. Therefore, if we have the set of Z, at isusulat natin yan, mahirap magsulat sa, okay, yung set of Z. So we can have this as 1, 2, 3, -2, -1, 0, 1, 2, and 3, then we have ellipsis. So this will be the set of integers. Okay? Ngayon, papunta tayo sa konsepto ng subset na yan later on. Kaya nga nag-i-exist yung tinatawag nating what? The set of real number line. Yung real number line natin. Yan, paano natin i-describe yung, okay, sandali lang. Sabi niya. Yung real number line natin, na usually we encounter this one in algebra. So 1, 2, 3, -1, -2, and -3. So kaya tinawag natin siyang real number line. Because all the numbers being used in the real number are presented in this line. So ito yung set of integers. This will be the set of whole numbers going to here. Then we have the set of negative integers. Ito siya. Set of counting numbers starts here. Tapos pag nilagay ko dito sa point na to, this is 1/2. Okay, then this is the set of rational numbers. Okay. Well, okay, so let us have this. Tingnan nga natin. Let us try to observe. If we have this, and we have this one. Okay. At ilalagay natin yung tatlong set yan. The set of R, the set of W, and the set of Z. Okay, so, i-delete ko muna ito. Ayan. Sino kayang nasa inner part? Yung W. Ayan. So dito ma'am, no? Tama? Ayan. Then, Z, and R. Okay. So saan tayo kuan? Papunta na tayo sa anong kuan kaya to? Anong konsepto nito?
Subset po, sir.
Okay, papunta na tayo ng subset. Okay, so papunta na tayo ng subset. So we have, so how we're going to describe this illustration?
Whole number po is a subset of Z, and Z and W are a subset of R.
Okay, so whole number is a subset of Z, or we can have this as yan, subset of what? Z,
Z and R.
Z is a subset of R. So yan. In other textbooks, they use this symbol. But pero yung mga iba, iba naman, may guhit dyan. Okay lang yun. Okay. So meaning, ang pinakamaraming elements dito, or the elements under the Z and W, is an element of the set of R. So alam naman natin, lahat ng numbers, pinakamaraming elements talaga yung set of R. All the numbers are subset of real numbers. And why Z is, W is a subset of Z, ito, because dito lang naman is from 0, 1, 2, 3, and so on and so forth, di ba? How about this? Papunta tayo sa, we have negative, no? Yan, negative 2, negative 1, 0, 1, 2, and so on and so forth. So nandito lang siya, meaning subset siya. Pero ito, subset niya lahat yung mga nandiyan sa baba. Okay? So, the symbol, null, denotes the empty or null set with no elements. Sometimes we wish to express the fact that one set is included in another. That every element of the first set is also an element of the second set. So we do so by saying that the first set is a subset of the second. So yun na yung natin, intro natin. Definition: if the set of S and T are sets, then we say that S is a subset of T, and we write this as S subset of T if every element of S is an element of T. Say for example, okay, the set of S is pi and square root of 2, and T is pi, 5, square root of 2. Okay, and we can say that S is a subset of T. Ito siya. Why? Kung titignan natin, yung S natin is having the element of pi, then square root of 2. And T is, we have pi, 5, and square root of 2. Okay. So we can say that S is a subset of T. Sabi niya, because in T, which is having the larger or elements, lahat ng elements ng T ay nandun kay S. If you're going to have the diagram, ito yung T, ito yung S. Okay? That's why S is a subset of T kasi ang elements under the S is we have pi and square root of 2. While sa T, meron tayong nakalabas which is 5. So under this T, we have 5, pi, and square root of 2. Pero yung S natin, nasa loob lang niya yung pi and square root of 2. Therefore, we can say that S is a subset of T. Ito siya. Okay. We write S is not a subset of 5 and square root of 2 because pi is what? Pi is an element of S, but pi is not an element of what? 5 and okay, ito medyo kwanto, medyo vague to, no? Okay. Pwede natin sabihin dito na S is not a subset of T is not a subset of S. No? Bakit kaya?
Kasi po may mga elements po na hindi part po ng S, kaya po naging tabs. Hindi po siya subset ng S.
Hindi siya. So ibig sabihin, dapat mas madami talaga yung power set natin, yung pinanggagalingan. Tama? It is like saying that A minus B is not equal to B minus A. Tignan natin yan. Diyan tayo papunta later. I-connect natin yan. So the positive integer, the set of positive integer is X such that X is a positive integer. Tama ba to?
Yes po, sir.
Kasi
Yung integers po ay part po ng positive. Kaya po subset siya ng all integers po.
So the set of integers, subset niya yung set of positive integers, which is right. Tama po. Tama. Thank you,
Yes,
sir.
sir.
Okay. So, ibig sabihin, if you're going to have the number line, yan. Ito yung integers natin. Then, -1, -2, and -3. Yan. Ito yung set of integers. Yan, yung buong yan. Then, subset niya yung positive integer, which is ito. Ito siya. Ito yung positive integer. Ito yung buong set of integers naman. So, parang ganito. Yan. Ito yung be your set. Okay. Hirap magsulat. Parang grade 1 pala pag nagsusulat ka ng yung top. Okay. How about this? Erase ko muna. Okay. Set of Q. Positive rational number is set of positive rational numbers is a subset of what? Rational number. Is this true?
Yes po, sir. Yung positive is a proper subset.
How about this?
Ganun din po, proper subset po ng real numbers po yung
Ng
positive.
real number, yung kanyang. So it is like saying that a set is always a subset of itself. Tama? Tama ba?
Yes po, sir.
Yung set niya ay pwede siyang maging subset ng kanyang sarili. And even the null set could be a subset of itself.
Yes po. Yes po.
Diyan na mag-i-exist yung cardinality of sets natin. Yung cardinality of sets. Okay. So cardinality or cardinal number, or we have the cardinality of set S, NS. Okay. For example, dali lang naman to. We have the set of S having the elements of 0, 1, and 2. Yung cardinality of S natin is what?
3 po, sir.
3, the number of the elements. Therefore, if you're going to identify the number of subsets of this one, we're going to use the 2 raised to n. No? So how many subsets are there if you have 3 elements? Having 0, 1, 2. So we have 2 raised to 3, or simply we have 8 subsets. Okay? Yan. Kaya kung isusulat natin yung subset niyan, so how we're going to generate 8 subsets? Start tayo sa how we're going to generate the 8 subsets out of this para makita natin. The subsets are, ito yung mga subsets natin. The null set, tama? What else?
0,
0,
1,
1,
2,
2,
0, 1,
may 1 to, no? Then,
0, 1 po.
0, 1,
0,
0, 2,
1,
1, 2. Ilan na? So 1, 2, 3, 4, 5, 6, 7, and the set itself. Tama? 1, 2, and 3. So the set is always a subset of itself. Kaya nagkaroon tayo ng 8. And always, yung null set is always a subset of the given set. Now, kahit nga null set, meron din tayong subset eh. For example, set of S is a null set. So how many subset? 1. Kasi yung nandun pa rin yung cardinality of the set of S is 0. Tama? And if you're going to apply 2 raised to n, 2 raised to 0 is equal to 1. So sino siya? Yung null set pa rin. So meron pa rin siyang subset. Thank you. Okay? So napapansin nyo yung pagkakakonect-connecta ng mga lessons? Okay? Magaling ko muna, no? Okay, let's go back. Kanina nag-introduce ako ng A minus B is not equal to B minus A. Bakit kaya? set A and B are two sets. Okay, I will give you a practical example. If we have set of A is having the element of A, B, and C, and B is B, C, and D. Yan. So what is the value of A minus B? So we have A. So ang reference set natin dyan is the set of A. Tama? Dito siya manggagaling. Yes. Then B minus A. Ang reference set mo dyan is set B. So ano kayang magiging
A po ba yun?
B? So B mawawala. Tama? C mawawala. So we have, tama ba?
Tama po, sir.
That's why this is an illustration that A minus B is not equal to B minus A. So kailan sila kaya mag-i-equal?
O same elements.
Same elements. Ano yung tinatawag nating equivalent sets or equal sets?
Equal sets po.
So what is the difference between the equal and the equivalent?
Yung equivalent po, sir, is meron pong same number of cardinal sets, while yung equal sets po, equal po yung elements.
Same value, no?
Yes.
Ayan, tama. So para i-equal lang natin. So for example, pag set of A is having the elements of 1, 2, and 3, and set of B having the elements of 1, 2, and 3. So this is an example of an equal sets. Tama?
Yes po, sir.
So because we have 3 number of elements at the same time, we have the same value of element. Can we consider this one also as an equivalent set?
Yes po, sir.
Okay. So how we're going to conclude?
Opo, sir.
Yes. Pag meron akong C dito, at meron akong 1, 3, 5, ang relationship nitong A and C are equivalent. Tama?
Yes po, sir. Equivalent.
But they are not equal.
Yes po, sir.
At meron akong set of D. Now we have A, B, C. So D and A are equivalent.
Yes po, sir.
Same as true with the C and D.
Yes po.
And same as true with B. So yun lang. Okay na. So pupunta tayo dyan. So the difference between equivalent and equal, an equal set is always equivalent. Tama? Tama ba
Yes
ako?
po.
But an equal set is not always an equivalent set.
Yes po, sir.
Sige, go. Observe that for any set S, S is a subset of S, that is S is a subset of itself. Yan na yun, nakuha natin kanina. Also observe that a null set is always a subset of S, no matter what set is. Okay? Perhaps the best way to say this is to ask yourself how it could be false. Okay? Then there is some X is an element of a null set which is not in S. But this is nonsense. Because there is no X is an element of null set. Period. Okay? We say the two sets S and T are equal. Yun kanina. If the set of S and T have the same elements, clearly then saying that S is equal to T is equivalent to saying that both S is a subset of T and T is a subset of S. But S is not equal to T. We say that S is a proper subset of T. Okay? We wish to emphasize that S is a proper subset. We write this doon. Okay, tingnan natin yung set of S natin. By providing example, sa palagay nyo, based on this, sino ang mas madaming elements? Ito,
Yung P po, sir.
yung P. Why?
Because po yung S is just a subset of P. Wherein all the sets of S are part of P po.
Okay. Pero dito, they are equal. Parang ganito siya. S is 1, 2, 3, 4. Yan. T equal yan. So 1, 2, 3, 4. Ito yung gustong sabihin ng equal sets. S is equal to T, then S and T have the same elements, clearly saying that okay, subset sila ng pareho. We can say that T is a subset of S and S is a subset of T because they have the same value of elements and same number of elements. Pero, just in case na meron tayong yan, 5 na, 1, 2, 3, 4, 5, magiging S now is a subset of T. Kaya sabi nga ni Sir Alex kanina, mas marami yung T. And we emphasize that S is not equal to T. Hindi na sila equal because we have here 4 elements and the other one we have 5 elements here. Okay? Kaya magiging yung S na ngayon ay magiging subset ng T or a proper subset of T. Okay. So bakit? Lagi niyong tatandaan that if we're going to have the subset of a given set, we're going to have 2 raised to n. And n stands for the cardinality of the given set. Cardinality of the given set. Okay. Next. We often consider sets are obtained by performing operations on one or more given set. For example, if S and T are sets, then their intersection denoted by S and T is equal to X such that X is an element of S and X is an element of T. And we have the union. Alam naman natin yan. Okay? Say for example, we have the set of S, we have A, B, C, D, and E. And we have the set of T is equal to the set of vowels. And so pag sinabi natin X such that X is an element of S and T, so the intersection between S and T are the common elements between S and T. No? Napakasimple na. So we have
A and E po.
A and E. So this will be the intersection. Okay. How about the union? Both of them.
Galing po A, B, C, D.
Okay. So we have A, B, C, D,
E, I, O.
E, I, O, U. Tama? So we have the union of the two. Meaning, we're going to combine. No? But do not repeat the elements. Okay, so that is the intersection and the union. Okay. Meron din tayong tinatawag dyan, darating din tayo sa universal sets. No? For example, the universal sets are the reference set. You have 1, 2, 3, 4, 5, 6. And the set of S is 1, 2, and T is 4, 5, 6. Now the complement of set S is the set of elements in S. Ika-cancel natin ay matitira dun sa U. No? That will be the complement. So 1 and 2, the complement will be
3, 4, 5, 6 po.
3, 4, 5, and 6. About T prime, we have 1, 2, and 3. 1, 2, and 3. Yan lang. So yun lang yung mga simple union and intersection. The union and intersection or more than two sets are defined in analogous way. For example, we have S intersection to T intersection to U, such that X is an element of S and X is an element of T and X is an element of U. So let's say for example, yung 1, 2, 3, 4 for 5 for the set of S, 2, 4, 6, and the intersection between S and T. Let's check 2, 4. Okay, so we have 2 and 4. And the union, 1, 2, 3, 4, 5, 6. Again, let S is 1, 2, 3, 4, 5. Okay. Do we have this? Do the intersection between set of S, then the real number is the S, Y.
Kasi po sir yung S is a subset of R. R the intersection of R.
Tama. Because S is a subset of real numbers. Tama? Tama. So parang nandito yung R sa labas. Gets? Nandito yung S. Lahat ng mga elements na nandito ay elements ni R. Ito rin, Si S lang. Therefore, the intersection between S and the real number is the S. Ito lang nasa loob. Ito lang yung common sa kanila. Tama? How about this? Bakit niya sinabing S union to R is equal to R? Using this, anong mangyayari?
Combination of R and S.
So, combination of the elements between R then S. Tama? So, sasama mo na lahat yan. That's why, lahat ng mga to, pag sinulat ko lahat ng elements, if I will write down all the elements here, lalabas dyan is the value of R or the real numbers. Okay? So, meron tayong if and only if. Ang symbol natin is a double arrow. Okay. So, if and only if. S is a union of T is equal to, sometimes the symbol, this one, okay, if and only if. Okay. S is a subset of T, if and only if, S union to T is equal to T. So ano ibig sabihin yan? If we're going to have a counter example. Okay. Kung bibigyan ako ng set of S, 1, 2, 3, 4. Ano kaya ang elements ng T? Para ma-proof ko yung gusto niya sabihin. So ano yung mga possible? Do T is having a larger number of elements as compared to S, or the same sila?
Same po, sir.
Pwedeng same sila? Tignan natin. So 1, 2, 3, 4. Pero 1 na. Pag same sila, pwede natin hindi niya nabanggit na S is a subset of T and T is a subset of S. Hindi niya nabanggit, di ba? Tama?
Yes.
So anong gagawin natin so that para medyo strong yung representation natin? Dito tayo. Yes, anyone? Basta ang manifestation natin is S is a subset of T and S union to T is equal to T. Yes.
Mas madami po, sir. 1, 2, 3, 4.
Yes, tama. Ito kasi, if I will use this one, ang manifestation lang natin, ito siguro. Tama? Ito.
Yes po.
But if I will use the set of S, 1, 2, 3, 4, sabi nga ni Sir Alex kanina, dagdagan natin ng 1, 2, 3, 4, and 5. Pwede na ba nating sabihin ito? So
Yes,
if S is a subset of T, yes, tama. Okay. Okay to, right? If and only if S union to T, pag sinabi kong S union to T, union ng dalawa, magkakaroon na ako ng 1, 2, 3, 4, and 5. Tama po?
Yes po, sir.
And S union to T now is equal to T. Gets?
Yes po, sir.
Para yung kwan lang natin dyan is, ito pwede rin. Tama? Ito ba pwede? Can we use this?
Yes po, sir.
Yun nga lang kasi, magkakaroon tayo ng parang, kasi pwede to, kasi pwedeng yung manifestation natin ng S is a subset of T or S is a subset of itself. Tama? Pwede rin. Yun nga lang, para magkaroon tayo ng strong views on how we're going to represent this one, magdagdag ka lang naman ng isa. But okay din to. Okay? One set of that is particular important in mathematics is the set of positive integers. Okay? In abstract algebra, the concept defined in terms of positive integers can often help to clarify what is going on. For this reason, methods for working with integers can be valuable tools on perhaps the most useful strategy is the mathematical induction. Okay? In mathematical inductions, actually, pag nag-solve tayo ng mathematical induction, almost the same po yung mga examples natin. But the proof is, lang naman, there are 3 steps in having the proof of the mathematical induction. Okay? Say for example, suppose we have in mind the statement, okay? P of n about the integer n. For example, the P of n might say it's n is even, n is square of some integer, or if P is a prime, then every group of order P, okay, has non-trivial center. This means mathematical induction provide us with a way of trying to prove the P sub n. Ano yung tawag natin sa P sub n? P sub n is your conjecture. No? Conjecture natin yung P sub n. And sometimes conjecture is related to hypothesis. No? So yung proving hypothesis din yan, proving conjecture. The technique rests on the intuitively acceptable action called the well-ordering principle. Every non-empty subset of a positive integer has the smallest element. Okay? So yun yung WOP. Do you have any background about principle of the mathematical induction? And I hope meron tayo lahat. Say that P sub n, and the statement associated with its positive integer n, and suppose the following conditions are satisfied. P sub n is true for any positive integer k. If P sub k is true, then P sub k plus 1 is also true. Then the statement P sub n is true for all positive integer n. So this will be the principle between the mathematical induction. In mathematical induction, there are 3 steps. The first is you're going to prove that the P sub 1, given the P sub n, that the P sub 1 is true. Then after that, you assume that when P sub 1 is true, then continue the process. Then assume that P sub k for any positive integer k is also true. Third one, since P sub k, you assume that P sub k is true, then P sub k plus 1 is also true. But you're going to show that this is true using the mathematical induction. Okay. If P sub 1 is true, then it follows P sub 2 is true, P sub 3 is true, and so on and so forth. Yan, dire-diretso na. Okay. So, pan tayo. Example. This is common. Common lang naman to. This is common example in mathematical induction. Tama? I think, maning-mani na ninyo to. Sino tong mga... Tao ba? We'll try to prove this one. Anyone? So the first step is, you're going to assume that this conjecture, ang tawag natin dito, 1 plus 1, 2 plus 3 is plus n is equal to n plus 1 all over 2. Your n here starts with, tandaan niyo, parang counting numbers to. 1, 1, 2, 3, and so on, so forth. So nag-start kayo palagi sa 1. Okay? That's why, if your n is equal to 1, ito yung mga n natin, 1, 2, 3, 4. If n is equal to 1, 1 yan. Tama? If n is equal to 2, nagkaroon tayo ng 2. If n is equal to 3, 3. If n is equal to 4, 4 na yan. So nag-start tayo 1, 2, 3, 4. Ngayon ang tanong ko, anong idadagdag mo sa n para maging 2 yung value? If your n is equal to 1, paano siya magiging equal to 2? Magpa-plus ka ng 1. Kaya tama bang, yes, thank you po. Tama bang n plus 1 is equal to 2? Kaya mayroon kang 2?
Yes po, sir.
Okay. If your n is equal to 2, nandito tayo, paano siya magiging equal to 3? Still, n plus 1 pa rin. Tama? Is equal to what? 3. Okay, so yun ang makikita natin later on. Okay? Move tayo. First step is, sabi ko sa inyo, you let P sub 1 is true. Get this one, n is equal to n plus 1 all over 2. So if your n is 1, 1 is equal to 1, then 1 plus 1 all over 2 is 1 is equal to 2 all over 2, or simply 1 is equal to 1. Tama? Therefore, i-assume natin, dito na, sandali. So 1 is equal to 2 all over 2, or simply 1 is equal to 1. Then we have P sub 1 is true. So true siya. If P sub 1 is true, then proceed to your proving. So anong susunod? So step number 1 po natin yan. Okay, step number 2. You're going to have P sub k is, you assume that P sub k is true. since P sub 1 is true. Okay. So P sub K 1 plus 2 plus 3 plus yan. You interchange now the 1 to K. Ano, N to K. K is equal to K plus 1 all over 2. Then assume now that P sub K is true. Bakit? Kasi si P sub 1 is true na. Okay, so step number 2. Step number 3. Since P sub 1 and P sub K are true, we're going to have P sub K plus 1. So 1 plus 3 plus 5 plus. Ay, so iba to. Dali. So P sub K is true. So okay na to. So, palitan ko na. Yan. Assume na lang natin that P sub K plus 1. Ito yung pang third natin. So 1 plus 2 plus 3 plus K plus, ano yung kung natin kanina? Paano siya nagiging 2? N plus 1? Tama po? Diba? If N is equal to 1, magiging 2 siya pag nag-N plus 1 ka. So plus, yung N natin, K plus 1 equals K plus 1 all over 2, yung lahat na plus, whatever the 1, K plus 1. Yan. Yan siya. So i-plus natin yung K plus 1 on both sides. Dito lang tayo magpe-perform ng operation. Bayaan nyo na yung nasa left side to show that the P sub N is true for all positive integer N. Yan. I-call ko na lang dito. So if I will have K plus 1, if I will have K plus 1 all over 2 plus K plus 1, magkakaroon ako ng LCD na 2. Tama? Yan po. Yan. So, yan. 2 divided by 2 is 1 times this 1. So, magkakaroon lang ako ng K plus 1 plus, yan. So, parang 2 divided by 1 is 2 times K plus 1. Yan. Then perform the operation. So, if I will remove now the parentheses, we have, ano siya? Okay, tulungan ako, baka natutulungan ko dahil iba yung gamit kong salamin. So, K squared
Plus 3K.
plus K, tama? Plus 2K plus 2. Tama po? All over. Ito, may kulang. Ano to? K lang. This one is K.
Ano po? K po. Bali 3K po, sir.
K ito, no? Tapos, magiging all over 2, no? So, punta na lang ako dito na lang, ha? Continue ko na lang, baliktad. Pero dapat pag nagpo-prove kayo dito, straight yan dito, no? Sa right side lang. Right side. Okay, so equals, magiging K squared plus 3K plus 2 all over 2. Tama?
Yes po, sir.
Factor? Anong factor natin dito? K plus 1, K plus 2 all over 2. So we proved that, no, so P sub K plus 1 is true for all positive integer N. Yan, for all positive integer N. So paano siya naging true? Babalikan ko kayo dito. Okay, so dito tayo nag-N. N. Nag-N kayo sa, di ba meron tayong N, ito, N plus 1 all over 2. Pero nag-N tayo saan? K plus 1, K plus 2 all over 2. Ang goal po natin dyan is to let N sa dulo, to let N ang goal mo dito sa una pa lang is to let n change into k plus 1. Pag napalabas mo to, na yung n mo ay pinalitan mo ng k plus 1, then p sub k plus 1 is true. So this one manifested in our proving. Tingnan natin to kung pareho sila. Pareho ba sila?
Yes po, sir.
If you're going to let your n as k plus 1, tignan niya, ito siya. Di ba yung n mo dyan, papalitan mo siya ng k plus 1, tama? Ito yun. This one. How about yung nasa loob? Paano nakita ang k plus 2?
Ano po, k plus 1 plus 0.
So naging parang ganito. K plus 1, yung n, plus 1. All over, nandun pa rin yung 2, tama? That's why k plus 1, then k plus 1 plus 1 is k plus 2 all over 2. So this is the proving of this mathematical induction. That's why this is 2. Gets po? Okay. Next, ito saya. Okay, how about this? Prove that 1 plus 2 or 3 plus 5 plus 2n minus 1 is equal to n squared. Okay, manifestation natin. How we're going to have this n? Ano yung sabi para madali sa atin? This is 1, 2, 3, and so on. Yung n mo dyan. When n is equal to 1, your value is 1. Bakit? When n is equal to 1, using this, 2n minus 1, 2 times 1 minus 1 is equal to 1. Tama ba? So, do we have this?
Yes po, sir.
Yes po, sir.
When your n is equal to 2, ano magiging value? 2 times 2 minus 1 using this. So 4 minus 1 is equal to 3. Ito siya. Tama ba? How about when n is equal to 3? What will happen?
5.
2 times 3 minus 1 minus 1 is equal to 5. Kaya okay ito. Tama? Okay ito. Ngayon, paano nagiging 3 pag galing ka sa 1? Ito yung dito mismo. Ito yung value niya. Okay. Ito. Yan. Paano nagiging 3 pag galing ka sa 1? So 1, 2, 3. Kanina, na-prove natin that using 2n minus 1, ito yung mga yon, na yung n mo is 1, 2, and 3. Nung nandito ako sa 1, ano ang magiging equation ko para maging 3?
N plus 2 po ba, sir?
N plus 2. Okay, tingnan natin sir. So n plus 2. Kung ang n mo ay 1, n plus 2 is 3. Tama? So 1 plus 2 equals 3. So okay siya. Pag ang n mo ay 2, 2 plus 2, 4. So ito hindi magbabalance ito kasi 5. So ano kaya?
4n minus 1.
4n minus 1. Tama ba yung narinig ko? Yes po. Okay, check. Tama ba? 4n minus 1?
Yes po. Try lang.
Try natin. Sige, okay lang. So we have, when n is equal to 1 tayo, no? So 4 times 1 minus 1, so 3. Okay siya. Pag 2 na, possible,
Parang hindi.
magiging 8, 7, no?
8 maging 7.
So
Hindi
hindi
na po.
lalabas yung 5. Okay, sige. Try pa. So bakit natin i-establish yan? Because that will be the time, yun yung idadagdag natin on both sides. We should try to have 2n plus 1. No, this one is possible. Can you check kung lalabas yung 135?
Yes
When n,
po.
when n is equal to 1, lalabas ba yung 3?
Yes po.
When n is equal to 2, lalabas ba yung 5 na sumusunod sa kanya?
Yes po.
So anong susunod sa 5?
7.
Tapos, okay. So 2n plus 1. Parang ganon, no?
Yes.
Tingnan natin. Tingnan natin. Okay? So, delete ko muna. Sarap mag-isip, no? Ng numero. Okay? Next. First step to prove this one is what? You're going to establish that the P sub 1 is true. Laging P sub 1 is true. Kasi pag nag-true siya sa P sub 1, follows true na yan. So 2n minus 1 is equal to n squared. So 2 times 1 minus 1 is equal to 1 squared. Tama? 2 minus 1 is 1 is equal to 1. So P sub 1 is true. Yan. So P sub 1 is true. Next, assume now that P sub k will be written as 1 plus 3 plus 5 plus, palitan nyo na yung n to k. 2k minus 1 is equal to k squared. Then assume that P sub k is true for all positive integer n because P sub 1 is true. Okay, next, you're going to have P sub k plus 1. So 1 plus 3 plus 5 plus then 2k minus 1 plus, ano yung tinan natin kanina? 2k plus 1, no? Kasi n yun.
Yes po, sir.
Is equal to k squared, yung tana, plus 2k plus 1. Tapos na. No. So, you're going to factor now that k squared plus 2k plus 1 is the same as k plus 1 squared ba? Tama.
Yes po, sir.
Na-satisfy ba natin yung n is equal to k plus 1 sa dulo? And if you're going to have n is equal to k plus 1, n squared yan. Tama. Therefore, k plus 1 squared. Then, this is k plus 1 is true for all positive integer, for all the set of positive integer n. Yan. So, ibig sabihin, nandun na yung k plus 1 mo. Pag pinalitan mo ng k plus 1 yan, yung n mo, yun na yun. Tapos meron siyang squared. So, nandun siya. So, ito na yung pinakamadali. Mas madali ito kaysa yung una. Can you follow?
Sir, may tanong lang po.
Okay.
Paano po naging k squared plus 2k plus 1 yung white po yung k plus 2? May
Saan po? Ay, dito, sir. Ito.
Yes po, sir. Yes, sir.
Okay. Tama na shortcut po. Thank you. Yan. Ay, may hirap mag-erase. Di ba, nag-add ka ng 2k plus 1 dito sa side na to. So, k squared yan, di ba? Plus 2k plus 1 din dito sa right side. Tama? Yan o. Nalala nyo, in-establish natin kanina yung, ano ba yun? Yan. So, you added 2k plus 1 kasi ito yung, di ba, sabi nyo kanina, 2n plus 1 para maging 3 itong susunod. Tama? When n, yan. Tapos lahat ng k mo ay papalitan mo ng n. So parang magiging 2k plus 1. So nung dinagdag mo siya dito sa left side, idadagdag mo rin siya doon sa right side. Now, if you're going to combine the similar terms, tanggalin mo lang naman yung open and close, kaya yun na siya. Then factor mo, yun ang lagyan mo. Okay na pa?
Okay po, sir. Thank you po.
Okay, ito kaya. Almost the same doon sa concept natin. Tama?
Yes po.
Yun nga lang meron siyang square.
Yes po, sir.
So, okay, assumption na naman natin. If your n, tama, laging tatandaan, yung guide niyo, etong mga to, 1, 2, 3 yan, yung n nyo dyan. No? Huwag kayong padala dyan sa given. Using this, when n is equal to 1, 2n minus 1, tapos meron kang squared. So, what? Equals 2 times 1 minus 1 squared. Tama? So, we have 1. 2 minus 1 is 1. Tapos may square ka. Tama? Ito siya, di ba? Gets? Tama pa? Paano kung n is equal to 2? Parang 2
3 squared.
n minus 1. So, okay na tayo dito sa 1 squared po, no?
Yes po, sir.
Squared equals 2 times 2 na, 2 minus 1 squared. So, 4 minus 1, 3 squared. Ito siya. Tama? Okay, how about this? Possible? When n is equal to 3? 5 squared na, no?
Yes po.
Yan. Ang tanong, anong idadagdag mo para maging 3 squared? Do we have the same?
Bali, 2n minus 1 squared. 2n plus 1 squared.
Possible, no? Yung kanina din. No? Kasi itong 2n plus 1 squared. When n is equal to 1, ano siya? 2 times 1 plus 1 squared. So, 2 plus 1 is 3 squared. Ito siya, no? So, nandito ka. When n is equal to 2, ano magiging sagot? 2 times 2 plus 1 squared. So, we have 5 squared. So, we have this. Gets? Okay na?
Yes po, sir.
Lumiliwanag na. Last, sumubra na yata. Di ba, last na to? Promise. Okay. Mag-declare muna ako, no? Now, assume now that P sub 1 is true. Okay. Ang pagpuprove niyan, ito lang sa ito. Okay. So, 2n minus 1 squared is equal to 1/3 or n cubed minus n. So, 2 times 1, okay na, 1 squared na to. No? So, 1/3 tapos, ano to? 4 times 1 minus 1. Tama? So, 1/3 times 3. Gets? Tama? 4 times 1 is 4 minus 1. 1. So, 1 is equal to 1. Therefore, P sub 1 is true. So, true tayo. So, I don't have any problem for that. So, continue. If P sub 1 is true, then what will happen? Assume that P sub k is also true. Paano siya isusulat? We have 1 squared plus 3 squared plus 5 squared plus dot 2k minus 1 squared equals 1/3. Tapos 4 p cube minus k then assume now that P sub k is 2. So true siya. When P sub k is true, then ano siya? Proceed to the P sub k plus 1. So, P sub k plus 1. 1 squared plus 3 squared plus 5 squared plus 2k minus 1 squared plus 2k plus 1 squared is equal to 1/3 or k plus 1 minus k plus 1 then close. Tama? Okay. Ikuan ko na lang. Ang right way dito lahat ang proving. Okay? Tandaan nyo, okay? Kaya lang ito. So equals, baba ko lang ng konti. Pero pag nag-prove kayo dito. So equals 1/3 4k plus 1 cube minus k plus 1. Okay. So we have 4. May kulang pala. Sandali, hindi kasya. Ito, may kulang akong plus dito. No? Tama.
Yung 2k plus 1 squared
Ilagay
po.
ko na dito. So 1/3 4k plus 1 cube minus k plus 1 plus. Pero ito ay naka-close, no? Yan. Plus 2k plus 1. Yun na yung cube, yung nandito. Or we can say that, can we have this para mas simplified na lang? 3, 4k plus 1 cube minus k plus 1 plus sandali lang, lipat ako saglit kasi maingay dito sa labas. Kapitbahay. So, plus 2. 2k plus 1 squared. So equals, ano yung kwan natin? K plus 1 cube. So 4 times cube of the first term, tama? Plus 3 times the square of the second term, plus 3 times the k plus the cube of the last term. 1. Okay. Minus k plus 1 all over 3 plus 2k plus 1 squared. Paki-check. Tama ba? Yung k plus 1, k cube plus 3k squared plus 3k plus 1. 3 cube of the first term times plus 3 times the square of the first term and the last term plus the square of the last term, which is 1 times 3. Okay na. Okay. So, hindi ba ako mag-erase? Dali, tingnan ko lang kapag iba na kasi ito eh. Okay na, erase na lang natin to tapos i-continue natin or i-preserve natin.
Sir, hindi ko po mag-get yung sa second line.
Second line. This one, ma'am, this one.
Yung one-third po. Yung bracket and then one-third.
Bracket and
Ito po sa pangalawang line. Sa
ito,
pangalawang
ito.
sulat niyo po.
Ito.
O, dito po sa pangalawa, sa taas pa. Yan po.
Yeah,
Yan buong yan, hindi ko po. Ito, yan po binilugan nyo. Nagets ko po yan. Kaya lang yung may kasunod pang negative 1 and then quantity 2k plus 1 cube.
Hindi, plus yan, ma'am, plus.
Plus ba yan? Plus pala yun.
Oo, tama. Okay na. Ito yung kon kasi. Ito yung 1/3. Ito yun, di ba?
Opo.
Tapos yung 4k cube minus k plus 1 kasi yung n mo nagiging k plus 1, tama?
Okay.
Oo. Tapos nag-plus ka on both side ng 2k plus 1 squared, tama? Squared yan. Okay? Tama?
Plus.
Oo. Kung ano yung pinlas mo dito,
Magpo-plus ka sa left
sabi-
side, ganun din sa right side.
okay.
Of course.
Ito naman, yung 1/3 4k plus 1 cube minus k plus 1 is the same as all over 3 na, no? Tama?
Yes po. Yes po.
Para mas na. Tapos nung kinuha mo yung cube of the binomial, tama? Ito siya. Gets?
Yes po.
Cube of the first term times or plus 3 times the square of the first term
Apo.
times 1 plus 3 times the first term times the square of the last term, which is 1, kaya 3k.
Apo.
Then the cube of the last term, which is
Last term.
1 minus ito.
Yung k plus 1.
Oo. Lumulokso kasi yung mga minus ko. Session na kasi ang dulas. Minus yan. Tama? Yan.
Apo. Okay.
Plus
Get na po.
2k plus 1. Okay. So,
Ito na, sir.
Pwede mo ba sa banggitin ko na lang po? Ang hirap pala. Ayan. 4k cube po. Ito na po yung value next na line. 4x cube plus 12k plus 11k. 11k po. Tapos minus 3. All over 3. Then plus 4k 4k cube squared plus 4k plus 1. Then equals po natin sa simplify po natin. We're going to get the LCD po. So copy lang po yung first term. 4k plus 12k. Ano po lang po pala pagkakot 12k squared plus 11k minus 3 po. Simple lang. Plus 12k plus 12k plus everything cancel out po yung 3. Then equals po 4k plus 24 so 24k squared 24k plus 23 23. Okay. All over ito dito. Tama po yun. Kasi po ba tayo ng sagot ng 4K,
Yes po.
4K cube plus 24K squared plus 23K over 3. Ayan.
So magiging 4, tama ba? Yung pa natin, magkakaroon ka ng k cube plus 3k squared plus 3k plus
Plus
1 minus k plus 1 plus lagay ko na lang yung 3 times 4k squared plus 4k plus 1. So over 3 na ako na. So 4k cube plus 12k squared plus 3k, 12k minus k plus or minus 1, no? Minus 1, tama ba?
Yes po, minus 1.
Bali po.
May kulang ako.
Opo. Plus 4 pa po bago mag-minus K po sa.
Wait. So 12k na ako dito, no? Plus 4 minus k minus 1 plus 12k squared, tama? Plus
12K po.
12k
Plus 3 po.
plus 3 over 3. Gets? So mag-i-end tayo ng 4k cube. Nice. Similar to. So 12 plus 12, no? Plus 24 ba? K squared
K squared po.
plus 11
23K po sir.
plus 20.
23K po.
So 12 plus 12 doon, no?
Tapos po minus K po.
Minus, so 23k. Tapos k na 4 minus 1 is 3, tama ba? Okay, check.
Yes po sir. Bali plus 6 po pala.
So 4k cube. Then okay, so we have 24k. Tapos saan ako? 4 minus 1 is 3. Tama ba? Let's check. Plus 3? Nagpa-plus 3 ba ako dito? May
Bali
plus 3 dito.
plus
3.
6 po.
So plus 6. Okay, ito na yun, no? Plus 6 all over
3 po.
3. Okay. Nag-end ba tayo dito?
Yes po sir. Bali na po yung plus 6. So kasi.
Okay. So yun na yung plus 6. Anong factor nito? Sa synthetic division natin, we have 4, no. We have 24, we have 23 and 6. Ito na natin ng k minus 1 o k plus 1. Ano kaya? Pwede? So 4, ano? Hanggang 4, negative 4, yes. What? Plus, no? So 20, tama? Tapos times this one, negative 20. So 3,
3.
negative,
So, hindi siya factor.
hindi siya factor.
Positive. 4. Hindi rin.
Hindi rin. So may possible ba na pwede natin? Sino ito kagabi eh? Lumabas naman. Wait. K plus 1.